morning. Hope you guys are doing well. We're going to go ahead and work today on section 5.5. So at this point, you guys should have your guided notes out for section 5.5. And let's go ahead and have those out. And then you can follow along and fill them in as we go. Okay, so section 5.5 deals with complex numbers and roots. So it's going to deal with this graph, f of x equals x squared plus 1. Hopefully you know enough that this graph is a quadratic function that opens up and it's also shifted up 1 unit. So if you think about the graph of this quadratic, it would look like this. So notice it is shifted up 1, it opens up. There are no x-intercepts. Okay, so there are no x-intercepts. So another way we could solve this is using algebra. If we set this equal to 0, we would subtract 1 from both sides. And when we do, we get negative 1 equals x squared. And then when we take the square root of both sides, you guys have been always told that you cannot do that. And that kind of always bothers me a little bit because you can. It's just defined as non-real solution. If you put this into your calculator, the square root of negative 1, you get that there is a non-real answer. So we say there are no real solutions. No real solutions. But today we are going to change that. You can find the solutions if we define the square root of a negative number, which is why imaginary numbers were invented. The imaginary unit I is defined as the square root of negative 1. So I is equal to the square root of negative 1. You can use the imaginary unit I, to write the square root of any negative number. Okay? So the next thing here talks about the imaginary unit is the square root of I is equal to the square root of negative 1. So for example, if I have basically what we're going to do with this today, this is a lot of confusing stuff up here. If I have the square root of negative 3, you can't leave the square root of negative 3. So what you're going to do is you would think of this as the square root of negative 1 and the square root of 3, and this is just I. That's an I. Okay, you're going to think of this as I times the square root of 3. So most of the times, you're just going to come straight from here to here. So another one would be the square root of negative 5. I'm just going to say, well, that's I square root of 5 because the negative gets kicked out as an I. And then likewise, if I have the square root of negative 20, what you can think about is put that with the perfect square. So this becomes 2I square root of 5. So you're going to put that negative with the perfect square because that negative always gets kicked out of the square root as an I. Okay? So your first examples here just say, write this or simplify this in terms of I. So again, you're going to do it just like we've been doing with simplifying square roots, except for now, anytime you have a negative underneath the radical, it gets kicked out as an I. And the reason is, again, many of you will just kick that out right away, but the reason you're allowed to do that is because you can think of this like that. So this is 5 times I, and the square root of 121 is 11. So this is just 55I, because I multiplied 5 times 11, that's 55. You have 55I. Okay, square root of negative 12. Again, I can put the negative with the 4 and 3, and then that negative square root of negative 4, that gets kicked out. That's 2I square root of 3. And the reason I can do that, another way to think of this is square root of negative 1, square root of 4, square root of 3. So that's I times 2 square root of 3. And it's just 2I square root of 3. So again, that's the long way. I don't expect you to write that. I want you to just kick it out as an I. So why don't you pause the video, try these two. As soon as you're done, replay it. Okay, so you should have these two done and have tried them. So square root of negative 36, so that's 2 times. I can think of this as negative 1 and positive 36. So that's just 2 times I times 6. So that's 12I. Again, there's different ways to get down to that 12i. But your answer is 12i. All right, I have a negative outside that just stays outside. I like to bring the I out right away. That negative that's in here gets kicked out as an I. And then I say, well, what does 96 split up into such that 1 is a perfect square? 16 goes into 96 6 times. So this is negative I times 4. So that's just negative 4i square root of 6. Again, I'm writing kind of multiple steps to show you how I arrived. So these are the same as what we've been doing in simplifying the square root of 96. It's just now we have an I outside because we are thinking of that as the square root of -1, which is just I. Okay? All right, so how does that change what we've been doing? Well, up until this point, if you guys had this problem and I asked you to solve for x, you would tell me there is no real solution. But there is a solution because we've isolated the x squared, so we're going to take the square root of each side. When I do, I'm not going to forget to put plus or minus out front because there's still 2 solutions. And the square root of -144 is 12i because the negative comes out as I, and the square root of 144 is 12. With 12i. All right, so on part B, again, these are easy because there's no B term, and anytime there's no B term, I can just use square roots. So I'm going to isolate my x squared. So I'm going to subtract the 90, and when I do, I get 5x squared equals -90. Still isolating that x squared, I'm going to divide both sides by 5. When I do, I get x squared equals -18. So isolate that x squared first. Now to undo the x squared, I'm going to square root both sides. I put x equals plus or minus. Now the square root of -18. I can come off to the side to show you. If you can do this in one step and know the answer, then write it down. This is how I would arrive at it. I think of this as -1 times 9 times 2. So that's I times 3 times the square root of 2. So I start seeing this over here as just 3i square root of 2. So eventually you guys need to go from here to here without really thinking about it too much. But I did the work off to the side so you can see how I arrived at that answer. Okay, part C. Again, solve. We don't have a B term. That always makes it easier. We're just going to try to find x squared, isolate the x squared, subtract 25, subtract 25. When I do, I get 9x squared equals -25. Divide both sides by 9. When I do, I get x squared equals, I cannot reduce this, so I'm going to leave -25 over 9. Now I'm going to take the square root of both sides. When I do, I don't forget to put a plus or minus. The square root of -25 is 5i, and the square root of 9 is 3. So it's plus or minus 5i over 3. You can think of this. This is the same as plus or minus 5/3 I. That is the same thing as 5i over 3. Okay. Well, there's numbers that are called complex numbers. And basically, a complex number is a number that can be written in the form a plus bi. So it has a real part, A, and an imaginary part, B. So you can see this is a complex number here. You have 3 plus 7i. This is a complex number, 3 plus 2/3 I. Here you have 4 minus I. So it has a real part and an imaginary part. So those are complex numbers. Every complex number has a real part and imaginary part. Okay, we talked about that. Real numbers are complex numbers where b is equal to 0. So basically you don't have that imaginary part. So if the b is 0, if the b is 0 and you have 0 times I, that would be 0. So you would just have an a. So then you would have a real number. These are sometimes called pure imaginary numbers. 2 complex numbers are equal if and only if their real parts are equal and their imaginary parts are equal, okay? So two complex numbers are equal if and only if their real parts are equal and their imaginary parts are equal. So if I have 2 plus 3i equals a plus b, and I'm saying then a would have to be 2 and b would have to be 3, because this is the, I guess it would be an I here, because b would be the imaginary part and a would be the real part. So this next part, these problems are very easy, but you guys tend to make these very difficult. And these are the ones that, ironically, of all the homework problems tonight, these are the ones that you guys often come in and say, I didn't get these. And they're really designed just to make you think about which piece is the real piece and which piece is the imaginary piece. Okay, so the real parts have to be equal and the imaginary parts have to be equal. So as I look at the left side, I have 2x minus 6i, and the right side I have negative 8 plus 20yi. So I first identify the real part. The real part on the left would be 2x, and the real part on the right would be negative 8. So over here, the real part is 2x, and over here, the real part is negative 8. So I'm just going to come off to the side and say, well, 2x has to equal negative 8. So if I divide by 2, x is negative 4. And then the imaginary part, this has to equal this. Those are your imaginary parts. So I would say, well, negative 6i has to equal 20yi. Well, basically your i's are going to go away because those are both being multiplied by I. Those go away. So you can just divide by 20, and you get negative 3/10 is equal to y. And we're done. And the reason the i's went away, because if you think about on both of these, if you divide by an I, divide by an I, the i's go away, and you're left with negative 6 equals 20y. All right, so let's take a look at this one. So again, you want to identify what's the real part on the left, what's the real part on the right. So these are both complex numbers. So the real part on the left is negative 8. The real part on the right is 5x. So my first equation is negative 8 equals 5x. Divide both sides by 5, and negative 8/5 equals x. Now, the imaginary parts, I got positive 6yi equals negative I square root of 6. So once again, if I think about dividing these by I, the i's cancel. I get 6y equals negative square root of 6. And so now I'm trying to solve for y. So I just divide by 6. And I get y equals negative square root of 6 over 6. I'm not allowed to reduce these because this top 6 is underneath the radical and the bottom 6 is not. So we cannot reduce those any further. We're done. Okay, so again, when you get to those ones in your homework tonight, identify the real parts and set them equal. Identify the imaginary parts, take out the i's and set them equal. Okay? All right, in my opinion, these are the most important problems in your homework tonight. The most important problems say, find the zeros of the function, and it just gives you a function. And remember, we've talked about zeros of the function. And we've talked about, to find the zeros, you come in and let the value of the function be 0. And remember, one of the ways that we talked about solving these was by graphing. So we could have come in here and tried to graph this, but what's going to happen is, since they're non-real numbers, it's not good. You're not able to graph this. So if you come in and put in x squared plus 10x plus 26, and then I do zoom 6 and I put this in there, I have no zeros. Notice there's no x-intercepts, so I have no zeros. So graphing does not work for non-real solutions. So my other two ways that I have is factoring or completing the square. So I could try to factor. A is 1, life is easy. I could ask myself what multiplies to give me 26 and adds to give me 10. But the only thing that multiplies to give me 26 is 1 and 26 and 2 and 13. And neither of those are going to add in any form to give me 10. So factoring does not work for complex solutions. So we've talked about graphing, that didn't work. Factoring didn't work. So the only other method that we have right now is completing the square. So remember, in completing the square, you want to get your x's on one side and your constants on the other. So I'm going to subtract this 26 over. So I get negative 26 equals x squared plus 10x. Now, a is 1. That's good. I'm ready to complete the square. Since a is 1, I can take half of 10. Half of 10 is 5, and I'm going to add 5 squared, which is 25. So whatever I do to one side, I have to add 5 squared or 25 to the other side. So when I do that, my right side factors into x plus 5 quantity squared. And my left side, well, 25 plus negative 26 is negative 1. And so now I'm going to take the square root. So far what we've done is same as last night up until this point. Because now my square and square root cancel. I get x plus 5. I do have to have a plus or minus out here. And we know the square root of negative 1 is the simple definition of I. So it's just I. Now to get x by itself, I'm going to subtract 5. And when I subtract 5, I get x equals, now remember you put the negative 5 first, plus or minus I. That's why I've had you guys developing those skills all week by putting that negative 5 plus or minus whatever the number is. And now we're done. So hopefully that wasn't too bad. All right, I would love for you guys to pause the video, try example B, see what you get, and then play the video and see how you did. Okay, so hopefully you've done part B, and let's see how you did. Find the 0. So we come in and we let g of x be 0, because the definition of finding the 0 of the function is let the value of the function be 0. Now, to get, again, to solve this, if you graph it, it's not going to work. You can't factor it. There's nothing that multiplies to give you 12 and adds to give you 4. So I'm going to subtract 12. I'm going to complete the square, because that's the only other method we know at this point in time. So I'm going to get this. Okay, so I got my x's on one side, constant on the other, and now a is 1, so that's good. I'm going to go ahead and take half of 4. Half of 4 is 2, and I'm going to add 2 squared. Whatever I add to one side, I have to add to the other side. So when I do, I get x plus 2 quantity squared, and then over here I get 4 plus negative 12, well, that's negative 8. Now I'm going to take the square root of each side. When I do, I get x plus 2 equals plus or minus. Now, square root of negative 8, remember, I'm going to think of this as negative 4 and 2, so that's 2i square root of 2. So that's how I get plus or minus 2i square root of 2. And now I subtract 2. And we're going to put that 2 first, that negative 2, plus or minus 2i square root of 2. Lots of 2's in that answer. Okay. All right. Well, the last piece is really easy. These two problems, those were the important parts. This last part is super, super easy. These two solutions are related. Notice that the real parts are negative 5. So notice that the real parts are exactly the same. They did not change. And notice that the imaginary parts are opposites. One is plus I square root of 10, and the other one's minus I square root of 10. So these complex numbers are related. They are called the complex conjugate of each other, negative 5 plus I square root of 10 and negative 5 minus I square root of 10. Those are called, complex conjugates. So another one would be 2 plus 3i. The complex conjugate to that is 2 minus 3i. If I give you negative 7 minus, let's not use 3 again. Let's say, 5i. Okay. The complex conjugate, the real part stays the same. It's the imaginary part that changes. Those are complex conjugates. So the real part stays the same. It's the imaginary part that is opposite. So these are called complex conjugates. We're going to use these a lot in the coming weeks. So when it says find the complex conjugate, it just wants the other piece. So you have 8 plus 5i. So the complex conjugate would just be 8 minus 5i. So the real part stays the same. The imaginary part changes in sign. Okay, so positive 6i, that is the only part we have here. So the complex conjugate would be negative 6i. And I always tell my students to think of this as 0 plus 6i. So the complex conjugate would be 0 minus 6i, or just negative 6i. On part C, I caution you because it's not written in what I call standard form. Standard form for complex numbers, you should always put your real part first. So the real part is the square root of 3. So this should be written as square root of 3 plus I. That's how I would write it. So then the complex conjugate would be square root of 3 minus I. And you're done. So that's all they wanted you to do there. Okay? All right, so your homework, let me grab it real quick. Your homework for tonight is, page 353 to 354, numbers, that's an S, numbers 18 to 34 even, and 38 to 56 even. That's a 5. So again, that would be on page 353 to 354, numbers 18 to 34 even, and 38 to 56 even. Okay, have a great day.